In this video, I'm going to demonstrate how to calculate some probabilities. Here's our first problem. We're told an urn contains 14 red balls and 12 black balls, and an urn's like a container. We're asked to calculate the probability of randomly selecting a red ball from the urn. Now, when I do these calculations, these probabilities, one way I like to think about it is like as a fraction. I'm just going to paraphrase here. The notation I'm using is probability red. That means, in my notation, probability the ball selected is red. And when I think about this type of a probability, I just draw this horizontal line and I think, well, how many ways can we draw a red ball? Well, there are 14 red balls, so there's 14 different ways we could get a red ball out of there. And then the denominator becomes the total number of things that can happen. There are 26 balls total, so there are 26 possibilities. This simplifies to 7/13. So the probability of selecting a red ball from this urn is 7/13. Here's another problem, a little more complicated. What's the probability of randomly selecting 2 balls from the urn below? And we're going to assume that we're sampling with replacement, which means we pull a ball out, put it back in, and then make our second selection. So this probability is first is red, and second is red. So the "and" is a key word here. It tells me I'm going to multiply the individual probabilities together. The probability the first is red times the probability the second is red. Now, when we're doing this in the textbook, this is called the multiplication rule. And the key question we have to ask ourselves is whether the two events are independent. In this case, they are independent because we're sampling with replacement. That means we would put the first ball back in. And so this probability is calculated by taking and multiplying the probability of drawing a red ball times the probability of drawing a red ball. And again, they're the same probability because we put that ball back in, the original ball, the first ball. And this simplifies to 49/169. And that is the probability. In this next problem, we're asked to calculate the same probability, but this time we're sampling without replacement. And what that means is the events are not independent. And that's going to make our calculation here a little bit more complicated. So we're looking for the probability the first is red and the second is red. So that probability statement looks the same. And this time we're going to need to calculate the probability the first is red, so that stays the same. But this time we have to multiply it by the probability the second is red, given that the first is red. So again, the first probability here is 7/13. But the second probability, I have to be a little bit careful here when I calculate that. So if the first is red, that means one of these red balls was selected. So there's one less ball in the urn. So now for the second draw, instead of having 26 total, we actually have 25. And instead of having 14 red balls, there are actually 13. So the chance of selecting a red ball, given we've already selected a red ball, is 13/25. And if we multiply this together, let's see, 7 times 13, that's 91. 13 times 25. I do not know what that is in my head. So I'm going to go off here, over here to the side, and calculate. Do this multiplication. I might be able to do it in my head, but there's a good chance I might make a mistake too. So let me just take a second here and do a little multiplication. 325 is what I'm getting. So this probability would be 91 3/25. 91 divided by 325. And again, we could write this as a fraction, or I'm sorry, as a decimal as well. But for these examples, I'm just going to leave them as fractions. Okay, there are a few probability problems. Please feel free to message me if you have any questions.